Welcome to this lesson on the equation of a line. We'll explore different ways to express linear equations, focusing on two important forms, point-slope form and slope-intercept form. Before we dive into the equations, let's understand what a slope is. The slope measures the steepness of a line. It tells us how much the y value changes when the x value increases by 1. Mathematically, we calculate slope using the formula m equals y2 minus y1 over x2 minus x1, where the points are represented as x1, y1, and x2, y2. Now, let's introduce the point-slope form of a line. If we know a point on the line x1, y1, and the slope m, we can write the equation as y minus y1 equals m times x minus x1. This form directly relates to the definition of slope. It says that the change in y over the change in x equals the slope m. Let's work through an example. Find the equation of a line with slope 2 that passes through the point 1, 3. Using the point-slope form, we substitute the values. Y minus 3 equals 2 times x minus 1. Expanding this, we get y minus 3 equals 2x minus 2. Rearranging to isolate y, we get y equals 2x plus 1. This brings us to the slope-intercept form. The slope-intercept form is written as y equals mx plus b, where m is the slope and b is the y-intercept, which is the y-coordinate of the point where the line crosses the y-axis. In our previous example, the equation y equals 2x plus 1 is already in slope-intercept form, where the slope is 2 and the y-intercept is 1. Let's see how to convert from point-slope form to slope-intercept form. Starting with y minus y1 equals m times x minus x1, we can expand the right side to get y minus y1 equals mx minus mx1. Rearranging to isolate y, we add y1 to both sides, y equals mx minus mx1 plus y1. Simplifying, we get y equals mx plus y1 minus mx1, which is in the form y equals mx plus b, where b equals y1 minus mx1. Let's do another example. Find the equation of a line passing through the points -2, 1, and 4, 5. First, we need to find the slope using the formula m equals y2 minus y1 over x2 minus x1. Substituting our points, we get m equals 5 minus 1 over 4 minus -2, which equals 4 over 6, or 2/3. Now, we can use either point with the point-slope form. Let's use -2, 1. We get y minus 1 equals 2/3 times x minus -2. Simplifying, y minus 1 equals 2/3 x plus 4/3. Finally, y equals 2/3 x plus 4/3 plus 1, which gives us y equals 2/3 x plus 7/3. Let's see a real-world application of linear equations. Imagine you're a rideshare driver. Your earnings depend on the distance traveled. You make $2 per mile, and there's a base fare of $3. We can model this with the equation y equals 2x plus 3, where y is your total earnings in dollars and x is the distance traveled in miles. This is in slope-intercept form, where the slope 2 represents the $2 per mile and the y-intercept 3 represents the $3 base fare. Let's summarize what we've learned. The point-slope form, y minus y1 equals m times x minus x1, is useful when we know a point on the line and its slope. The slope-intercept form, y equals mx plus b, is useful when we know the slope and y-intercept. Point-slope form is helpful for finding a line through a specific point, while slope-intercept form makes it easy to identify the slope and y-intercept at a glance. Both forms have their uses in mathematics and real-world applications. Remember, any line can be expressed in either form, and you can convert between them using algebraic manipulation.